Hey guys, we're here with some tech tips regarding using sprockets with your Actobotics build system. Specifically, we'll be talking mostly about quarter-inch pitch sprockets and chain in this video. And kind of what started this whole thing is Kyle and I were talking about one tip in particular, and so that's going to be our first tip. So in this little assembly here, you can see I have a set screw hub and a clamping hub, and they each have a sprocket, but the difference is the clamping hub has an 1/8 inch spacer. That's a hub spacer in there. And the reason you're going to need that if you're using a clamping hub is to space off the chain itself so that it doesn't interfere with that pinch bolt. So it clears the pinch bolt and that will run nicely now.
Few things to note: the set screw hub version, because it's the same shape all the way around on all four corners, it clears just fine. There's no reason for a hub spacer in there, so you can just bolt that straight to a hub. A few things on the design of the hub sprockets: you'll notice they all have a 1/2 inch bore. You may be thinking, well, I've got a 1/4 inch shaft or a 3/16 or some odd shaft other than a 1/2 inch. On our hubs, we have a protrusion sticking out, so no matter what size shaft you run through there, if you get the correct hub, your sprocket's going to fit over that 1/2 inch OD protrusion. It's going to be concentric with the hub, and that way it's going to spin true on the shaft. Now, he's got two hubs over there. One's a clamping, one's a set screw hub. If the set screw hub would work on that without the hub spacer, you may ask yourself, why would I use that? Or why would I use the clamping instead of the set screw? Well, the clamping hub is going to transfer a lot more torque. It's not going to spin as easily, or a set screw hub on a round shaft like that may spin and may mar the shaft. We have several different versions of the hubs, both in clamping and set screw. This one that I grabbed on the way in has a hex bore, so if you had a hex shaft, or if you had a D shaft with a D hub or something like that, then you don't have to worry too much about it spinning inside of there, since the bore has a profile and the shaft running through has that same profile, and it's not just a perfect circle.
There are going to be times where you want to use two sprockets concentrically on the same shaft, and so we wanted to give a quick example of that. Again, in this assembly, I'm using a clamping hub with a 1/8 inch spacer, but then I'm using a 1/4 inch spacer to space off the two sprockets. And of course, these could be different sizes, but that 1/4 inch spacer is going to keep them away from each other, and they'll spin freely. And you can either have one going to one place and the other going in a different direction, or you could just double up your chain for more torque. Next, we have a D shaft going into a D hub, and we wanted to use a larger sprocket in this assembly. And as you can see, if we just had a D hub, there's no way it would attach to this larger sprocket because it has a 1.5 inch pattern, and the D hub has a 770 pattern. So this is a great use case for using a pattern adapter to go from the 770 to 1.5 inch.
One thing to note on that, there are screws holding the sprocket, or screws holding the hub spacer onto the sprocket. Those are 1/4 inch length. You can run about any head style you want because they're out on their own surface. There's no obstruction there if you want to run a truss head or a pan head or something like that. On the interior, because your screws are going to be fitting down inside of that 1 inch bore of the sprocket, you really need to run socket head screws. They've got a little bit smaller outside diameter on that screw, so they fit down in. And on this assembly, we use the 632 by 3/8 inch screws to run through the hub adapter and use up all the threads on the hub.
Next up, we have an example of a 1.5 inch pattern hub going to a 1.5 inch pattern sprocket, so obviously no adapter is needed in that case. And the 1.5 inch faced tapped clamping hub in this case is 1 inch ID bore. And the interesting thing about that particular clamp is we have it both in tapped and through hole. So here's an example of an assembly we're using that hub with the through hole option on there, where we're going up through the sprocket and then through the hub into the bottom of these bottom tapped clamping mounts. And so that comes in handy in various situations.
Just a quick tip on assembling something like this. we have this 1.5 inch pattern hub in several different bores. Now, in a case where the shaft size and the bore of the sprocket or gear, whatever you're putting on it, is the same, when you're trying to assemble those two parts in order to keep them very concentric with one another, what I usually do is I slide a shaft through the two parts and then put the screws in. That'll keep it nice and centered and kind of alleviate any wobble as that thing runs. Now, if it was a smaller shaft size, we have this hub in a 15, 21, 22, all kinds of different bores, then that's really not going to matter as much, just due to the fact that your shaft, when you run it through there, is not going to make contact with the edge of the bore on the sprocket or whatever the attaching component is.
And that's a great tip. Anytime you're running a shaft or tube through the center of hubs and bearings and various pieces of an assembly, just make sure it goes through before you tighten everything up, and you'll save yourself a lot of time and frustration that way. Next up, we have a 1-inch ID heavy-duty clamping hub that is attached to this sprocket here, and we're showing a few different screw types going into that.
We have the standard socket head screws. Those are going to be the most common, found in a hardware store. They have a 3/16 Allen drive, so that's a good large size Allen to where you can really put a lot of torque on these screws and tighten everything down very tightly. The other style, they're a little bit newer screw style for us. We offer the low head socket head screws in 1/4 20. So they're going to be a lot lower head height. Maybe you have limited clearance on your assembly, or maybe you just like the look of it. I personally like the look of these a lot better on a robotics assembly than I do the standard ones, if you're able to get these tight enough for the application you're using them in. They're a smaller drive style. They use an 1/8 inch Allen drive instead of the 3/16, so you can't necessarily get as much torque on them, but they're still a 1/4 20 screw, so it's a good size, and they're going to work well in many applications as well.
There are going to be times that you want to use sprockets directly on your servo. We have a few options for that as well.
The first option I want to talk about is probably the most simple. We have an aluminum 10-tooth sprocket. It's got a broach on the back side that just matches the standard servo spline on a high-tech servo. We also have this for 25-tooth splines, so Spring RC, Futaba, some of the newer high-techs. So almost all of your popular servos we're going to offer this for. Now, on servos, you're limited on rotation. Most servos rotate about 180 degrees max, so that means you're not going to be able to drive much chain with a servo if it's in its standard form. There are a few ways to drive more chain. One is going to be to run a larger sprocket on the servo. So in this case, I've grabbed a servo horn that has the Actobotics hub pattern, and then grabbed one of our hub sprockets. This is an acetal hub sprocket instead of the aluminum sprockets we were talking about. I did this because you can grab any size of hub sprocket that you want and put that straight onto a servo. The aluminum servo horn allows for a nice fit onto the servo, and then it holds the sprocket in place as well using the 770 hub pattern. Now, to attach this sprocket onto the hub, I grabbed truss head screws. They're 632 by 1/4 inch. I like the truss head screws when using a plastic sprocket because it's going to give you a little more surface area in between the bottom side of the screw and the top of the plastic sprocket. You can use a socket head, but there's not going to be as much contact, and your screw is going to dig into that plastic a little bit more. Now, when this rotates 180 degrees, it's going to move a lot more chain than the 10-tooth sprocket, just due to the fact that there are more teeth on this. If you guys want to do a wheel assembly or a winch or something with a servo, you might consider using a continuous rotation servo. This happens to be a 1425 CR servo, which is a factory continuous high-tech servo. So it's going to rotate in either direction without bounds. But please note that this doesn't have any feedback, so you wouldn't be able to tell it to go to a specific location by the PWM signal sent. You're going to be calling out the speed at which it rotates. If you want to upgrade from this, the 2645 CRH servo, also made by Hitech, would be a nice one to use. It's a little more linear as far as how it ramps up the speed, and it has more torque compared to the 1425. It also has metal gears inside, so it's going to be good for high torque applications.
While I really like the compactness of our broached servo sprocket, a lot of times I opt for more usability out of parts so I can use it in various different situations, which is why I often like to go the route of a broached servo hub that I can then put on a hub sprocket or a hub gear, or throw a beam on there to have it, articulate around. I like the more flexibility that gives me, but there are times that you're just going to need the compactness of that single piece that goes on there.
Sure, if you're prototyping something, then the more modular parts are probably going to be a little bit better. If it's something that you know your end goal and it's going to be something that you leave together, you might want to go the more simple route and just grab a part that is intended just for that purpose.
So as we kind of move down the table here, we've gone from big and down to servos, but finally there are going to be times where you have a really compact space to work within, or you're doing tabletop robotics where there's going to be less forces involved, and so for projects like that, we have a smaller option as well for our chain and sprockets.
The .1227 chain and sprockets is going to be under half the size of the 1/4 inch that we've been talking about on this whole video. These are going to be for lower torque applications. Most of those are going to be a plain bore, so it's just a cylindrical hole going through the sprocket. It's going to fit down onto a shaft, and the friction in between the shaft and the sprocket is going to be what allows this to drive the shaft that it's on. If you put a lot of torque on that or try to ramp up in speed very quickly, there's a possibility that this sprocket would slip on the shaft. But given the size, chances are you're going to be working with a low torque setup that's a very tiny assembly. Now, we also have sprockets that have a broach into the back of them, so similar to the aluminum, it's going to fit straight onto a servo and allow you to drive chain and sprockets that way.
And finally, we're going to leave you with a parting tip that will save you time and frustration. You might have noticed that we have both plastic and metal 1/4 inch pitch chain. And while a lot of times you might gravitate directly towards metal, if you get yourself a bunch of the plastic chain for prototyping, you're going to save yourself a lot of time, a lot of frustration. It's super easy to snap it apart, snap it together. You're not going to need a chain breaker or master links or anything like that until you get your assembly just the way you want it, and then you'll know exactly how many links you need, and you can set up your metal chain and drop it in place.
Yeah, the metal chain, sometimes there is the misconception that you can just press a pin out and then press it back in and continue lengthening and shortening this chain just like the plastic chain that we have. I guess it's possible that you could probably press that pin back in there, but it's really not designed that way. We have a chain breaker that would press it out for you in case you want to make this a shorter loop. We also sell the master links and the add and connect links, so you can, with enough parts, increase and decrease the length of this chain. But like Jason said, the plastic chain is awful nice for building something that you don't know exactly how long that chain needs to be, or maybe you're just building your toolbox of parts and you want to tinker around and build something and then take it apart and repurpose those parts for your next project.
As always, if you have questions, send us an email at tech@servocity.com.